In Chapter 10 of Learning Web Development with Seaside, we enhance the Los Boquitas application with a new component embedded in an existing component. We launch the Seaside One-Click Experience and then create a new domain class, LBEvent, with instance variables for who, what, when, and where. We use Smalltalk's refactoring tool to add getter and setter methods for each of the instance variables. The tool shows us the methods that will be added, and when we accept the new methods, there are 8 methods in the accessing category for this new class. We create a method to compare events. This allows sorting by the date-time of the event. We create an initialize method that sets each of the instance variables to a reasonable default value. Now we need a place to save the events. In most applications, this would require setting up a relational database, but Smalltalk provides a simpler approach. We can create a class instance variable that will hold a collection of events. We can create a class-side method to return the collection. Note that this method includes a lazy initialization in which the variable is assigned an initial value if it is unassigned. Now we add a class-side method to create some sample events. We have included in the method an expression in a comment that when executed will call the method to be evaluated, creating the sample events. Now we create a new web component that will be used to display the event list. While it's not necessary, we can register the component as a root-level application so that we can see that it works. We add a minimal rendering method and then view it in a web browser. The component will make use of a built-in Seaside component for rendering tabular data. To do this, we'll create 4 methods that define the columns of the report. We then create an initialize method that defines a WA table report with the 4 columns. Now we can replace our render method with something that renders the table. When we view the application in a web browser, we see that we have a table with 3 rows and 4 columns. Now that we have a component to render the events, we'll modify our main component to reference this new report. We add an instance variable, main area, to our main component. We then modify the sidebar to add an anchor that loads our new scheduling component into the main area instance variable. When we view the application in a web browser, we see that the event links exist, but clicking on it does not have any visible impact. This is because we're not using the instance variable yet. We modify the method that renders the main area so that if there is a component in the instance variable, we render that component. Otherwise, we render the image. When we return to the web browser and restart the application, we see that clicking on the events link changes the main area. We then modify the sidebar so the heading says menu and there is another anchor labeled home. When we view the page in a web browser, we see that the home and events links are run up against each other. This can be easily fixed by adding a break between them. Now, when we view the application in a web browser, we can switch between home and events. The use of a conditional or if statement in the render method suggests that some refactoring might be needed. We will create a new component, LBHome, that simply displays the image of the children playing soccer. Now we can return to the main component and add an initialize method to set the main area to the new home component. This allows us to simplify the render method so that it always renders the main area, and there's no conditional. We can then make a simple modification to the sidebar menu so that clicking the home link installs a new home component. Viewing the application in a web browser confirms that our refactoring has not broken anything. Now we'd like to be able to do something with an event. We'll add an action column to the report that offers a delete link. We modify the initialize method so that we have 5 columns instead of 4. When we view the application in a web browser, we see that each event has a delete link. When we click on one of the delete links, Seaside gives us an error, component not found when processing callbacks. As suggested in the error report, a likely cause is that we did not implement the children method. This method lets the Seaside framework know about subcomponents we've displayed in our rendering process. Here, the scheduling component has rendered the table report. We still get the error, but this time at a different location because the main component is now rendering the schedule component. So we need to add a children method to the main component, identifying the main area. Now when we click on a delete link, we get a different error. Message not understood because we're sending the message delete, but there's no method to implement that message. Adding that method is simple enough. The implementation simply removes the specified event from the list of all events. We can return to the web browser and click refresh. This resends the web request, and we see that the list of events is down from 3 to 2. At this point, it would be nice to have a JavaScript confirmation to validate the delete. We'll modify the column so that it includes an on-click event. We can return to our web browser and see that the delete attempt requires a confirmation. Canceling the delete leaves the event. Confirming the delete removes the event. At this point, we can save our code and quit the Seaside One-Click Experience. For more information, go to seaside.gemstone.com/tutorial.